Well, thanks a lot for the opportunity. And I was in New Zealand 2 weeks ago, but I couldn't stay any longer. I have to admit, I was happy to see today that when I checked the weather, that from rainy Seattle, that summer hadn't really arrived to Wellington. When I was there, it was not very much like summer. So I'm really not in a position to discuss the kind of cutting edge issues that most of your talks have been. So rather, I thought I'd take advantage of my seniority to give a little bit of history of how stock assessment evolved, and to use the fact that the meeting in New Zealand to discuss this in the context of assessment evolution in New Zealand in the years between 1990 and about 2005, when I was intensively involved in New Zealand assessments. And I think there's some lessons that are very general from that experience. And that'll lead me at the end to some thoughts on the importance of stock assessment in global food production, best practices in stock assessment, and the future of stock assessment. But first, I want to caution that my experience, which began in Western Canada, then moved to the South Pacific Commission and Pacific Tunas, and then to Seattle, with some considerable time spent in New Zealand and Australia, has been largely in the Pacific, Pacific focus, with relatively little exposure to the Atlantic. And I recognize that many of the key elements in modern stock assessment come from the Atlantic, whether it was the early recognition and development of age data from scales and otoliths, to the early pioneers such as Johann Hjort and Michael Graham and others. I was fortunate enough early in my career to know Bill Ricker when he was still active in Nanaimo, and to meet a couple times John Gulland and Ray Beverton. And I was also lucky enough to work with John Pope for many years on the scientific committee of the Commission for the Conservation of Southern Bluefin Tuna. So I think one thing that distinguishes the Atlantic from the Pacific is that stock assessment came much later to the Pacific, probably because industrial fishing really came much later. And one exception to this was the formation of the International Pacific Halibut Commission in 1923. So now I just want to dive into a little history of my interaction in New Zealand. So many of you probably know that New Zealand came relatively late to industrial fishing and the stock assessments. So in the late 1980s, New Zealand had a quota management system put in place largely on the advice from economists, probably not realizing that there wasn't the science infrastructure to calculate quotas. But the quota management system essentially required assessment of stocks. So at that time, there was a statutory authority, the New Zealand Fishing Industry Board, or FIB, that represented the fishing industry in its relationships with the government. And the FIB wanted to understand how the process of the quota management system was going to work, how it would affect them, and how stock assessment worked. And they originally contracted MRAG and John Gulland for advice. So my recollection is that was just on the orange roughy stock assessment. But then beginning in 1989, they contracted the University of Washington to help them develop science capacity to understand and participate in the assessment process. Now, that project was initially led at UW by Ellen Pickich, and over the years, a large number of students and postdocs from UW participated, and most notably, most of you will recognize Murdoch McAllister, Andre Punt, Anna Parma, Mark Maunder, Carolina Mintavera, Brandon Chasko, Trevor Branch, and Arnie Magnuson were all part at various times of that University of Washington team. And I apologize to others who may have been part of that and I didn't list here. And in the 1990s, the Fishing Industry Board did develop a science program, initially led by Paul Starr, and then later, somewhere around 2000, Kevin Stokes took over. So starting with their first assessments, and indeed throughout almost all of the 1990s, individual scientists working for the Ministry of Fisheries and then later NIWA performed assessments for different species, and each individual scientist used their own preferred population dynamics model and the method for determining the best fit to the data and the method for calculating uncertainty when uncertainty was explicitly considered. The individual scientist's choice of methods was influenced by their own experience in modeling and statistics, as well as the nature of data they had available, the computer software, and generally individual preference. It was very much an individual choice on how they perform the assessment. Now, in some cases, the methods were widely used internationally, such as VPA was used for at least one assessment. But in other cases, the methods were essentially developed by the individual scientist. So one of the consequences was there was absolutely no consistency in how models were fit to data, how uncertainty was calculated, et cetera. It was really just a hodgepodge of one fishery was done one way, one was done another. So we, being the combination of the University of Washington and Fishing Industry Board staff, we brought Bayesian methods to the table with age-structured stock assessment models. Well, when there was age-structured data. And our approach was to provide a second opinion on assessments of the major fisheries using our own model. The Bayesian approach was initially met with considerable opposition from the NIWA scientists. Pretty strong opposition. At that time, Bayesian methods weren't totally accepted within the statistical community, and statisticians often fell either into a pro or an anti-Bayesian camp. So we did our first assessment on Hoki in 1991, and we were essentially ignored. The 1991 plenary document did not report on our assessment or the Bayesian methods at all. Now, as I said, we were under a lot of pressure regarding whether Bayesian methods were even statistically valid or appropriate. And we were just getting up to speed on actually implementing it for full age-structured models. But we were really lucky in that we were aided both technically and spiritually by Adrian Raftery and Judy Zay of the UW Statistics Department, who were well-known Bayesian statisticians, and they were already using similar age-structured population dynamics models for bowhead whales in the International Whaling Commission. And if my memory serves me well, I think at the time, Doug Butterworth was probably the only one doing anything that could be called a Bayesian stock assessment for any fish stocks at around 1990, 1991. So over the 1990s, NIWA continued with individual scientists using different methods. And our group, in 1997, we developed a generalized age-structured Bayesian model called Coleraine, which is a high-end New Zealand wine. And I'm sure Mark has several bottles he'll be serving at the end of the meeting today. Back in Seattle at that time, Rick Mathod at NOAA was continuing to refine his stock synthesis generalized model. And he eventually added AD Model Builder and Bayesian analysis about 2005 to that. Yeah, I should say that Coleraine was running with AD Model Builder as its fitting engine from the start. So in 1963, Patrick Cordew, who was working for NIWA, developed the first age-structured model for New Zealand data by NIWA with a method he called minimum integrated average expected loss, or MILE. And from 1993 until 2001, there was an annual presentation of our Bayesian approach versus the MILE results for the largest fishery, which Hoki, which I think that at the time it was probably only Hoki and southern blue whiting, which had age-structured data. and Southern Blue Whiting was, I think, done by BPA at the time. So as a result of these two methods, there was an annual, often acrimonious, discussion within the working groups on the advantages of and disadvantages of both methods, and no agreement was reached. I remember Andre Punt wrote a critique about and published a critique of Mile somewhere in that period. So in 1999, the Ministry of Fisheries commissioned two external consultants. Again, you may know them, Pat Sullivan and Terry Quinn, from the US to review the methods used for Hoki and make recommendations about the most appropriate method. They concluded that both methods had advantages and disadvantages and just basically said, carry on using both methods. So it wasn't very satisfactory, certainly from our perspective. However, within NIWA, attitudes were changing as new staff had been recruited. And again, my failing memory is that Richard O'Driscoll and Alistair Dunn had both been recruited, and they had been exposed to and were certainly not hostile to Bayesian analysis. But the real crux came in 2001 when Patrick Ordu publicly disavowed Miles, saying it really wasn't working, and then he left NIWA. And so they really had no stock assessment model that could deal with catch-at age data. And so what they did, quite sensibly, I would say, was they developed their own stock assessment model called Castle, which on the website it's now called Castle 2, which was in essence a more sophisticated version of Coleraine program with quite a few new features. And Castle was then started to be used in 2002 for Hoki assessments. But at its core, it was very similar to Coleraine. It was an age-structured stock assessment model using Bayesian methods to fit uncertainty. And I believe it also used ADMB or another auto-differentiation algorithm. Okay, so from a personal perspective, I felt that through the 1990s, we had lost every battle over stock assessment methods. But in 2001, we won the war when NIWA basically adopted a Bayesian method as more or less similar to what we'd been done. So I would take away from the lessons from this period that you really need consistency in models and an approach to uncertainty. You don't want to have a smorgasbord of methods you've got to sort through for different stocks. And I think ICES has always pushed towards a consistency in modeling approaches. The second lesson is having alternative assessments is an important quality check that should periodically be applied and perhaps included as part of the regular assessment process. And I heard a lot about multiple models and ensemble discussions earlier today, and I think that that's certainly not a new message. And I should mention that in addition to Coleraine, in the 1990s, Paul Starr and Paul Breen had developed a model used for rock lobsters that was size structured rather than age structured. And while some different methods like stock synthesis, and I believe Castle, can certainly handle size data as well as age data, there's certainly a lot of room for stock alone link-based methods such as multi-fan CL. Okay, one more little walk back memory lane, and that has to do with one of the most controversial fisheries in New Zealand, Snapper 1 fishery, which is a high value fishery that takes place in around Auckland and is important both as a commercial and recreational fishery. Unlike the acrimonious debates we were having with NIWA staff over Hoki, the NIWA staff and the industry consultants were collaborating on an assessment, and they had agreed on model equations and both implemented computer code to assess the stock. The industry consultant was a PhD student at UW named Mark Maunder. And I'm pretty sure the NIWA staff were Nick Davies and Dave Gilbert. And they're around 94, 95. Both assessments concluded that stock was well below BMSY, but if you looked at the yield curve, the yield at the current biomass was 90% of MSY. Okay? The Ministry of Fisheries Policy Branch felt compelled by the Fisheries Act to reduce catches to rebuild the stock to MSY, and the model suggested this would require, because it's a long-lived fish, a 50% reduction in catch for about 20 years. I'm sure Mark may be able to correct me on some of these at the end of my presentation. So that would have been really, from an industry perspective, catastrophic. And the fishing industry and the Maori fisheries owners appealed in this decision, in essence arguing it made no sense to lose half of the catch for 20 years to achieve a 10% theoretical increase. At current market prices, that 50% of the quota had a market value of somewhere on the order of 100 million New Zealand dollars. I also, on behalf of industry, submitted a deposition that was really quite straightforward. It said no sensible person would take a 50% salary cut for 20 years for a promised 10% pay rise. But the court was not swayed by my logic and agreed that the Fisheries Act required the rebuilding. But the court also concluded that insufficient consultation had been done regarding the social and economic impacts, and they delayed the quota cut for a year to allow for that economic and social consultation. At a subsequent working group meeting, one of the industry representatives, I think it was Von Wilkinson, tabled some new unreported catch data from the past, because they were using catch histories going back, I believe, to 1900. And he'd found this unreported catch from some fleet, and he tabled it. And when Mark added this additional catch to the model, the stock would rebuild on its own without a quota cut. And they're just showing how sensitive some of these models can be to some of the data inputs. So naturally, this was greeted with great satisfaction among the industry stakeholders. However, when Mark got in touch with his NIWA colleagues, the additional catch hadn't made any difference to their projections. In theory, the models were identical. So again, as I remember, Mark flew up, I think it was to Whangarei, to visit his NIWA colleagues, and they spent several days comparing computer codes, and they found an error in the NIWA code. And when it was corrected, it also predicted rebuilding without a quota cut, and there was no quota cut. So from what I know, and from what I know at the time, I think the Snapper 1 population seems to have done well, with both recreational and commercial fisheries performing well, but I'm not totally up to date on this. So what's the lesson from this? A, it's almost always worth having a second opinion. And in many cases, this would involve the fishing industry to do their own assessment. People make mistakes, computer coding errors are made, and that would have been something like $100 million mistake if that quota cut had gone ahead. So Mark asked me to give advice regarding best practice. Now, I'm not in a position to give any technical advice. You people in the audience are the experts, but I'd emphasize a couple key points. First, stock assessment is important for food production and people's livelihoods, and there's a great need for more resources to be put into getting it right. Of course, much of this need is for better data, but certainly more work is needed on methods and implementation as well. Certainly, multiple models should be considered best practice, and frequent peer review should be best practice. Computer codes need to be carefully tested. And again, I believe ICES for many years had standard codes of various forms of EPA that have been carefully tested, and certainly NOAA has been moving towards some very standard software to really make sure that the code's as debugged as humanly possible. So let me conclude with just a few thoughts on where I see stock assessment and, to an extent, fisheries management going. I think, and I don't think any of these are revolutionary. I see increasing reliance on management procedures with sort of high-end assessments being used as a check on the status rather than central as an input to the harvest control rules. I know that has been the case for the New Zealand rock lobster assessment for many, many years. And I think also the southern bluefin tuna, and places where management procedures have been put in place, the role of the stock assessment is as a check rather than central to determining TACs. I think we can look forward to improved indices of abundance from a whole bunch of technology, including genetics, things like close kin mark recapture, remote sensing, drones, and rapid collection of data from sensors on fishing vessels. And these themselves could be key inputs to management procedures, much as close kin mark recapture is central to the southern bluefin tuna management procedure. And the place I see the biggest challenge, or the frontier of challenge, is how we deal with multi-species tropical fisheries and data poor assessment methods. So I want to thank you for the opportunity to share some of this old history and wish you all good luck in making stock assessments better. So, thank you.
Thanks, Ray. Appreciate you having the time to give us that presentation. Does anyone have any questions for Ray?
Mark, also feel free to correct any of my errors in my history.
Well, your memory is much better than mine. My memory on that's very vague.
I actually wrote this down about 15 years ago.
Okay. Well, I'll trust your memory over mine anyway. Yeah, Arnie, you have a question?
Yeah, thanks, Ray, for an excellent overview. One thing I know that you've been focusing on in recent years are areas where you do not have the sort of what we see as typical sort of assessment management systems. Things, big countries like, I don't know, India, China, and things like that. Can you maybe, elaborate a little bit on your current thoughts, whether our assessment methods have much bearing there, or what might be upcoming?
Well, I mean, the assessment methods are intrinsically the ones that I think we generally deal with are single species, and I think the areas that don't have very intense fisheries management tend to be more multi-species, but certainly India and China have a number of large-scale fisheries that are probably right for proper assessment. This is not directly related to the assessment methodology, but one of my really serious concerns is spreading the idea that good fisheries management involves setting TACs. And I know China has 5 pilot projects on trying to implement TACs. And for most of the big fisheries of South and Southeast Asia, it's never going to work. And I last year or the year before, I looked at U.S. fisheries, and I was surprised that only 25% of the economic value of U.S. Commercial fisheries comes from fisheries that are effectively managed by TACs. It is not the norm. It is unusual for U.S. fisheries. Almost all the exceptions are invertebrates, the Gulf of Maine lobster fishery, the Atlantic sea scallop fishery, the West Coast Dungeness crab fishery. None of the salmon fisheries are managed by TACs. And it just seems to be that other countries have accepted that you're not doing it right if you don't have TACs, and for much of the world, they can't measure catch. There's too many boats, there's too many landing ports, etc. And those fisheries are probably almost certainly going to be best managed by effort, time, and area closures rather than setting TACs. But there's an enormous need for both better data and better and just better capacity in the organizations to do assessments. And I know, I've been working quite closely with the Yellow Sea Fisheries Research Institute in China. And what's happened there is they've said, okay, we need to do stock assessments. I think it came down on high, do stock assessments. And so they basically just told some of their staff they have to start doing stock assessments. So we've been helping them train, but they don't know anything about the fisheries. There's just such a long way to go to get people up to capacity. And I think it's Mark Maunder, my old collaborator, he used to say the most important thing for modelers to understand is to know your data. And again, I see this problem, particularly in developing countries, is the people who collect the data are just totally different and detached from the people who just get given some data, and I've asked them, again, mostly with the Chinese, okay, where's the data come from? How's it collected? They don't know. And as another anecdote, we've also been doing a lot of training in Peru, Chile, and Mexico. The Peruvian field staff were charged with getting length data. The idea is you go out to a landing port, meet a vessel, measure some of the fish. Well, the fishermen wouldn't let them measure the fish unless they bought them. And they had limited budgets for that. So they bought a lot of small fish because they got a much bigger sample size for the same amount of money. That they did not have any idea how that data was being used. So there was a total disconnect between the data collection and the analysis. And that's a place that just needs to be a lot more connection.
Okay, thanks, Ray. Any other questions? I have a question, Ray. So this is more of a technical question, but you mentioned there's a lot of need for data poor stock assessments. And there's a lot of methods out there for doing data poor assessments. But there are also a few people, particularly from the sort of the complicated age-structured stock assessment field, that suggest that we should be using the complicated stock assessment models with assumptions and uncertainty about those assumptions included to do the data poor modeling, rather than using these data poor approaches that kind of hide the assumptions, particularly if you haven't done your management strategy evaluation to test whether or not the data poor method works well in that particular case. Do you have any opinions on that?
Yeah, I guess first, I'm in many ways I'm sort of in sympathy with the skeptics like Carl Walters, who thinks that we've gone overboard with really complicated assessments, and in some sense, the better your data, the less you need the complexities of the assessments, and that's why I think. So that one example, I've been working with some of Carl's students on Peruvian anchoveta, and there they have 2 surveys a year. And do you really need an assessment? You need an assessment if you want to calculate reference points, but do you even really need reference points? You can, that's another issue. I'm not convinced that we need to use complicated methods. But I do think we need to really understand everything that's going in, and we a number of us have long been critics of the catch MSY and how so I would always want pretty simple population dynamics equations, and it is pretty simple idea that fish get a year older every year, so. And I think that again, I haven't used them, but I think the is it something like simple stock synthesis, or there's a version of stock synthesis that really is not much more than a a simple age-structured biomass dynamics model, you know, that, I can't remember what I called when I first built those things, but it tracks age structure, but with a whole bunch of simplifying assumptions about selectivity, et cetera. So I would say, you know, you don't need the complexities of modern high-end things where you have, you know, multiple fleets and all of that, but you do want there to be some really clear biological assumptions inside whatever you're doing.
Thanks, Ray. Anyone else have any questions that they'd like to ask Ray about his presentation or anything to do with stock assessment modeling, good practices, or stock assessment modeling in general? No? Okay, well, thanks a lot, Ray.